All right, so now that we have done that theorem about how f is increasing when f prime is positive, you can prove a similar theorem which says that f is decreasing when f prime is negative. Okay, I didn't prove that because it's pretty much exactly the same, but with all the inequalities just flipped around. So we're going to use that to do an example. Right, so the example is, here's a function, f of x equals e to the x times x squared minus 3. And we want to know what are the intervals on which this function is increasing or decreasing. Now, obviously, we could look at a graph and figure out what this is, but the whole point of like chapter 4, or a significant part of chapter 4, is doing some analysis on functions without looking at a graph. Right? So I'm going to teach you all the rigorous mathematical calculus strategies for analyzing a function, whether it's increasing or decreasing, where its maximums and minimums in are, and all that kind of stuff, with just doing like mathematical type analysis type stuff, not looking at graphs. So what we've learned is that we need to figure out where this function's derivative is positive and negative. So first, let's calculate its derivative. We'll do some differentiation over here. This is a product of two functions, right? Multiplied together here. So I've got to use the product rule. Derivative of the first function, e to the x, is just itself. So we'll take that times the second function. And we'll say plus. The first function left alone, which is still e to the x, times the derivative of the second function. And the derivative of the second function there would just be 2x plus, or 2x minus 0. So just 2x. Let's simplify that a little bit. I'm going to factor out the e to the x, and then what's left over is going to be x squared plus 2x minus 3. I wrote them in that order, x squared plus 2x minus 3, because I wanted to write it like a quadratic. And so we can look at this, and you can actually factor this quadratic here, and we get e to the x times x plus 3 times x minus 1. So this is going to be a function that we're gonna need to work with here in just a moment. So the next thing to say is a really big important thing here. Remember how we defined critical numbers back in 4.1? Well, critical numbers are an important thing to use here in this section as well, because critical numbers are not only candidates for local extremes, like local maximums and local minimums, but critical numbers are also possible. They're also possible places where a function f prime changes sign, which would be positive to negative or negative to positive. Remember the sign, the sign spelled like that, S-I-G-N. The sign of a number is the quality of being positive or negative. Okay? So, what we're going to do to figure out where the function changes sign is we're going to take the derivative, to figure out where the derivative changes sign, we're going to take that derivative and determine where it's equal to 0 and where it's undefined. Let's do undefined first. F prime is undefined e to the x times x plus 3 times x minus 1. I'm pretty sure the domain of this is just going to be all real numbers, right? There's nothing you could do to this to make it undefined. There's nothing you could put in. So never. Well, that's great. Okay. What about f prime equal to 0? F prime is equal to 0 when... All right, we have three possibilities. We have three factors, so we have three possibilities. What if e to the x equals 0? Well, that's never going to happen. E to the x can't ever equal 0. Its domain its range is positive numbers only. So that's not going to happen. How about x plus 3? If that equals 0, then x would have to be negative 3, right? So negative 3. And then if x minus 1 were equal to 0, well, then x would have to equal positive 1. So we have x equals negative 3 and positive 1. So there we go. Those are our critical numbers. Those are the only critical numbers for this function. Critical numbers. So now, to figure out where f prime is positive or negative, we'll build a sign chart. A sign chart. I think we've done this once before. I did it when we were talking about position, velocity, and acceleration. I'm kind of expecting that you would have seen a sign chart back in pre-calculus or college algebra. but if not, they're not too hard to do. So I'll show you how to do it. What we do is we're going to plot all of the values where the function is either 0 or undefined. And this is a sign chart for f prime. Okay, we're looking for the sign of f prime here. So for us, we're going to plot our critical numbers, which are -3 and +1. And make sure you plot them in the right order, right? -3 is to the left of +1. There we go. Then what we want to do is pick one, like, representative number from each of the 3 intervals that are formed. So in this case, I plotted 2 numbers, and so I have 3 intervals, and so I got to pick a number over here, like -4, and I got to pick a number between -3 and 1, like 0, for example, and I've got to pick a number that's bigger than 1, so I'm going to pick 2. And it really literally doesn't matter what number you pick as long as they're in the intervals. Okay, if 0 is available, I always like to pick 0 because it's easy to work with. So now what we're going to do is we're going to test the value of f prime at each of those numbers. And all we really need to do is stick the number into f prime and determine if it's going to be positive or negative. So this will be e to the power -4 times -4 plus 3 times -4 minus 1. And we're going to do a sign analysis. E to the power -4, that part is going to be positive. Actually, it's going to be positive no matter what. E to any power is positive. So that's never really going to matter. -4 plus 3 is a negative number, right? Because that's going to be -1. And then -4 minus 1 is also a negative number. That's -5. So overall, positive times negative, that's going to be positive, right? Because we have 2 negatives that'll cancel each other out. So this is going to be positive at -4. And the fact that it's positive at -4 means it's positive on the entire interval that -4 is representing. And the reason for that is because we've already identified all of the places where this function is either equal to 0 or undefined, and that is at -3 and 1. So there's no other discontinuities in this function. So there's no way that it can change from positive to negative without either going through the x-axis, which would make it equal to 0, or being discontinuous and jumping over the x-axis somehow. So we've already identified all the places that happens, which means if it's positive at one place on an interval, it's positive on the entire interval. It can never flip over and be negative. So now we'll look at the next interval. Now we do f prime of 0. And for f prime of 0, we're going to get e to the 0 times 0 plus 3, which is just 3, times 0 minus 1, which is -1. And this whole thing is e to the 0 is equal to +1, so it's positive. 3 is positive, and -1 is negative. So overall, with 2 positives and a negative, this is going to be negative, less than 0. So negative at 0, and therefore negative on the interval that 0 was representing. And lastly, we'll do it at 2, f prime of 2. And I'm running out of space, so you do e squared times 2 plus 3 times 2 minus 1, and those are all positive. You can check a little more detail if you want, but you will discover that's a positive number. So it's positive at 2, and therefore positive on that interval. So that's how you do a sign chart. Sign charts, the purpose of a sign chart is to take a function and figure out whether it's positive or negative, and then determine that for the entire domain of that function. So you're finding all the intervals where it's positive and all the intervals where it's negative. So now we can make the conclusion, make a conclusion from this sign chart. Because this is a sign chart for f prime, right? Because we're talking about the sign of the first derivative, the positives and the negatives correspond to when the f, the original function, is increasing or decreasing. So we can conclude that f is increasing on the interval -∞ to -3. That's this interval on the left over here. And also on the interval from 1 out to infinity. Like that. You never use the test values, by the way. You never use the test values. Sometimes people use a different color for test values. You might want to do that, like I'm in red here. Right? So the test values are just temporary values that you're checking, just to see where the pluses and minuses are. But now we're using the actual critical numbers to divide up the intervals, and we find the one on the left and the one on the right. By the way, you always use open parentheses, so open intervals, when you're talking about increasing and decreasing. Always parentheses, never square brackets. So we concluded where it's increasing, and then we conclude it's decreasing on the interval from -3 to 1. And that's it for this particular part. We're actually going to come back to this example in a future video, so I'm going to write to be continued over here. There's something else we're going to do with this example, but for now we have done the first part, which I guess we could call this like part A. Find intervals where f is increasing and decreasing. We've done that.